Hello, this is our second video of Chapter 5, Section 1, and we're going to be graphing polynomial functions using transformations. So this is our first stage in our attempt to graphing polynomial functions. So these polynomial functions are going to be somewhat special, okay? So let's begin. So we're going to graph the function f of x equals 1 minus x to the fifth. So we're going to do this in stages, and we're going to use the idea that we know what an x to the fifth graph looks like, and we know how to apply transformations from a previous chapter, 3.5 to be precise. Okay? So we begin by graphing the y equals x to the fifth. And then we put a negative out front, because that's a negative x to the fifth, and so that flips the graph over. And then adding 1 is a vertical shift upward. So that moves the graph up 1 unit. So that third graph is the final stage. As a matter of fact, we probably did this exact same example in Chapter 3, Section 5. We just didn't call them polynomial functions back in those days. What we did was we just called it an x to the fifth graph. We didn't give it that special name. So x to the fifth is actually a power function, which is also a polynomial function. And so what we're going to do is just do this in stages. We're going to turn the graph upside down because it's negative, and we're going to move it up 1 unit. So there it completes the graph of this function. So let's look at this example here. Graphing a polynomial function using transformations. So 1/2 times x minus 1 to the fourth power. So we look at the first graph. That's y equals x to the fourth. Remember, it's a power function, so it's 0, 0, 1, 1, negative 1, 1 are the three key points there. Notice it also goes in the same direction on both. They both go up, just like a y equals x squared graph does. And then we're going to have an x minus 1, so that's going to move the graph 1 unit to the right. So 0, 0's new home is 1, 0. 1, 1's new home is 2, 1. And negative 1, 1's new home is 0, 1. And then we take the 1/2. And what does that 1/2 do to it? Yep, it compresses it by a factor of 1/2. So you take all the y coordinates and multiply them by 1/2, but in essence what that does, it flattens the graph out. And again, we could have very well done this problem back in Chapter 3, Section 5. And you're like, well, why are we revisiting it here? Is because it's getting us warmed up to do the bigger type of functions, the polynomial function. And you're like, well, this is a polynomial function. Yeah. But what we're doing is we're basing this on what a polynomial looks like when it's a power function. So the power function is kind of the first stage. And then when we start doing the other things, we just got to add a few other things called intercepts. You've heard of those. We're going to add something else called turning points, and we'll talk about those as well. So we just got to add a few more concepts, and then we can graduate from power functions using transformations to full-fledged polynomial functions. We just got to add a few concepts along the way to get there, though. Okay? So this is all we want to do here. Is I just want to introduce these graphs again, but give it a more special name, the power functions, using transformations as opposed to what we did earlier back in Chapter 3, Section 5. So any questions, let me know. And you have a good day.